Hi, my name's Stephen Burgess. I'm a data engineer at HGA, HGA Architects and Engineers. It's an architecture firm with locations across the US. Uh, I've been working there for about a year, and before that, I've been a software engineer since 2015 after graduating with my bachelor's in computer science from State University of New York, Purchase College. And before I get started, I just wanted to thank the new stars of data, DataGrillen, for having me. Thanks to Edward, my mentor, and to Ben. And thanks as well to my team at HGA, who have helped me in my journey to become a data engineer. Earlier this year, in March, I became Microsoft certified as Fabric Analytics Engineer. And at HGA, we use Fabric every day, and our process is to build out a robust data warehouse to expand the the data analysis capacities at HGA. So what I'd like to talk about today is an approach to data warehousing of breaking up your data warehouse conceptually into several tiers or layers and using this concept and this design pattern to help identify the needs and concerns of a data pipeline from your source data to your analytics landing point. And this idea comes from Databricks Delta Lake, although the idea of having hops in a data pipeline has been around for a long time. The Databricks Delta Lake conception of this, breaking it up into these medallion ideas, so that's bronze, silver, gold, is a metaphor connecting with the idea of medals. And for instance, in the Olympics, our last presenter talked a little bit about that. And I really couldn't have asked for a better lead up to my presentation. His presentation about which implementation of Fabric to use, whether you have a single workspace, multiple workspaces, a single tenant, or multiple tenants. After you've made that choice with your team, now you've got the problem of how to get your data from your sources to your analysis landing point. So that's what I'd like to talk about today. Why should we think about tiers in your data warehouse? So two main reasons why to take this approach are to have a robust approach to data lineage, as well as flexibility in your reporting and in your data analysis down the line. As far as data lineage goes, data lineage is the concept of keeping track of every step that your data goes through from your sources to your analysis. And having that lineage allows you to have observability into how your data is moved from place to place. And that can give you a lot of confidence that your data is accurate, it's current, and it means what you think it means. So as far as data lineage goes, connecting your downstream reporting needs with your data sources and having that high level of observability is very important for the analysis step, because when we're doing analysis of our data, having the confidence that the data means what you think it means is crucial, because that data is being used to make business decisions. And at first, as you're building out a data warehouse, you may have some fairly simple reporting needs. And over time, you can expand your capacity at your firm or company to build even stronger reporting, more complex, incorporating ideas and tools like machine learning. And in order to be able to accommodate those changes down the line, because your reporting needs, they'll always change. In order to accommodate that, you really want to think ahead of time of each step of your data pipeline to ensure that you can accommodate those changes and future-proof your warehouse. By taking an approach like this, you can really lay a foundation that will allow you to change your data warehouse over time to accommodate those needs as they come up, and as tools like AI, allow you to do new and more powerful analysis of your data. So to start with, I wanted to just talk about some of the terminology we'll be using here. It can be confusing at times when certain terms mean more than one thing, and I don't want to assume too much about the level of familiarity with anybody listening to some of these concepts. So in Microsoft Fabric, a data warehouse is a very specific term. So that's going to be a Synapse data warehouse that has Delta Parquet backing and allows you to query a structured database using T-SQL and using the SQL language that many developers are already familiar with. In a more general sense, a data warehouse can refer to any company who collects data in any format and any type of database, whether that's SQL Server, whether that's Databricks, Snowflake, or MySQL. Any number of tools can be used to create a data warehouse in the general sense. So when I'm talking about that, I like to refer to that in the verb of data warehousing. Data warehousing is the practice of taking data from a variety of different sources, collecting it and organizing it for analysis. At many companies in the past, that could even look like having an Excel spreadsheet that's loaded directly into Power BI and having analysis like that. Using that Excel spreadsheet, that is a form of data warehousing in itself. But now we have some really powerful tools, such as those available in Fabric, that expand our capacity to be able to do data warehousing. And one of those tools is called a data warehouse, a Synapse data warehouse. Similar to how data warehouse can have a general meaning and a very specific meaning, the same can be said for data pipeline. A data pipeline can refer in general to taking data from one source and bringing it into a place where you can do analysis of it. So to go back to my previous example, you could even call loading a bunch of data into Microsoft Excel and taking that Excel spreadsheet and loading it into Power BI. That can be a data pipeline as well. In the Microsoft Fabric concept, in the Microsoft Fabric world, a data pipeline also has a very specific meaning. And if you were here earlier for the presentation by the presenter, Anne, she discussed the specific kind of data pipeline in Microsoft Fabric. And this is a tool that I use frequently as well. And so that tool is a data orchestration tool. It allows you to take data from one source and load it into another. A pipeline it's a logical grouping of activities that together perform a task. You can use a Microsoft Fabric data pipeline in the data factory, and there are also many other tools you can use to do this. Dagster is an example outside of the Microsoft world that you can use to create a data pipeline. A data flow is a tool from Fabric as well that allows you to load and transform data into a new location and use very little code and use a user interface to do some powerful transformation of data. And one approach that I really like to use is to create a data flow. The Gen 2 kind is my preferred type of data flow. To use a data flow to extract, transform, and load data, take that data flow and put it into a Microsoft data pipeline. By doing that, you get all the power of the data flow, and then you get the orchestration and scheduling power of the data pipeline. So Microsoft Fabric, as it continues to evolve its feature set, offers a lot of really powerful tools to do things that can be synchronized with each other. You can use a data flow in a data pipeline to really maximize your ability to take data, transform it, and load it into a new location for analysis. I also wanted to touch really quickly on the terms ETL and ELT. They come up a lot, and I think it's helpful to kind of just touch on them. So extract, transform, and load is ETL, and this is used commonly and colloquially to talk about data pipelines. The concept here is that you have a source of data, you take that data out of it or extract it, you transform that data and load it into your data warehouse. This process is often, ETL is often used to describe a variety of different approaches that may not take this exact order. And one different approach is the ELT, or extract, load, and transform approach. That's an approach used by Databricks Delta Lake, which, that tool is informing a lot of this presentation. So extract, load, and transform is the approach that connects to the Medallion tier architecture. In the Medallion tier architecture, you have a bronze layer, a silver layer, and a gold layer. That bronze layer is where you've loaded data, and the silver layer is where you've transformed the data. So we can contrast that against the more traditional or original ETL approach, where at the same time that you're extracting, you're also transforming before you're loading. And there's some benefits that come to moving from an ETL approach to an ELT approach, and that's what I'm talking about today. And to recap some of these terminologies, we have data warehouses. So in the Microsoft Fabric context, that refers specifically to a Synapse data warehouse. And a Synapse data warehouse is a database-like feature which you can query with SQL or T-SQL. And it's used specifically for online analytical processing. And underneath that tool, there is Delta Parquet files. However, when you're interacting with it, it's very similar to interacting with a SQL Server database. And you can use a lot of the same skills that you use with SQL Server in a Synapse data warehouse. So one of the benefits of using a data warehouse is you can use existing skill sets in SQL Server. If you have people at your company who are familiar with SQL Server, very natural to move from that to a data warehouse. And that can be contrasted against a lakehouse, which we'll talk about in a second. Before we get there, the concept of a data lake is important to understand. So a data lake is any source of data which can have a mix of unstructured and semi-structured files. So that can look like OneDrive, that can look like a shared file system. And in the Microsoft Azure and Fabric context, that can look like blob storage. So you'll have a blob storage container, and you can load any number of different files into that. That can look like CSV files. It can look like Excel files. You can load Parquet in there, and you could also load any number of different file types, such as rich text files and Word documents. The data lake is then a foundation for the concept of a data lakehouse. In Fabric, the data lakehouse is built on that blob storage underneath it, and takes it one step further to allow you features that are very similar to the data warehouse, such as having SQL endpoints. You can query the data in a data lakehouse in the way that you can't with a data warehouse. A data warehouse won't allow you to upload CSV files, rich text files, or images. And a data lakehouse, you have a combination of having a SQL-like ability to interact with your data there, as well as being able to load in different files. And that can allow for some really powerful synergies with those two different types of data, structured and unstructured. And that allows for a lot of capabilities using a tool like a notebook to say, take an image that's loaded into a lakehouse, do some analysis with machine learning, such as image recognition, and then take the results of that processing that you've done and load it back into your lakehouse in a structured way, and then query that down the line. So a lakehouse and a data warehouse have a certain level of ACID compliance. A data warehouse is ACID compliant. A data lakehouse may or may not be, depending on your implementation there, and a data lake will not be ACID compliant. So a data lakehouse will be ACID compliant when you're using a tool like Delta Lake, which we'll also talk about in a minute. So just to touch a little bit more on Parquet, the Parquet file format is a very powerful tool, and it's underlying these technologies of the Synapse Data Warehouse and the Data Lakehouse. Parquet file format was not a file format I was familiar with before I started my role as a data engineer, but it allows has a lot of features that are very powerful for data analysis, data storage. And I think it's really helpful to understand the difference between this and something like CSV or JSON. So a Parquet file is going to be stored in a columnar way, whereas CSV would be rows. So many people on this call should be familiar with CSVs. You'll open that up. You may or may not have a title row, which indicates the name or the title of each column there. And then you'll have a series of rows where they are all related to each other, and they have the full set of each row. So as far as compression of those files go, you have a mix of file types, of column types, which can make compression fairly difficult. Compared to Parquet, the data is stored in a column. So if you have a column of all integer types, numbers, then when you store it in a Parquet file format, everything in that file format will have the same type of an integer, and that allows you to compress it very powerfully. Another important distinction of Parquet versus CSV is that Parquet files are self-describing. They contain metadata about the data that's contained within them. That allows for a lot of powerful features, and that is what underlies the ability to do time travel and to see how a file changes over time. That can enable schema evolution. So you can use this tool to store your data and evolve it over time and be able to see how it changes over time. Parquet is a very powerful file type, and it's what's underlying a lot of these tools and enabling very powerful processing and storage in Microsoft Fabric. So it's great to help to really understand that This is the file type that's underlying a lot of this technology. So to cover the three different approaches, we have the data warehouse approach, the data lake approach, and the data lake house approach. For the data warehouse, this is more of a traditional approach, and this is where data engineering and data warehousing started from. You'll have structured data, such as in a SQL Server database. You'll have an ETL pipeline, so that's going to extract the data, transform it, and then load it. And your data warehouse, prior to Fabric, that could look like another SQL Server database or Postgres or some other form of database. The data warehouse then is what's going to be able to underlie your ability to do business intelligence, reports, data analysis, and empower your data-driven decision making. So then after having this tool for a long time, people started to recognize a need to include semi-structured and unstructured data. So semi-structured could be a CSV, unstructured, you can see some icons here of an image, video, audio, rich text, Word documents. There's a need to incorporate these other file types and non-structured, unstructured data into a data warehouse. So that need is where the concept of the data lake came from. You'll load your unstructured data into a blob storage or some other file format. And then from there, you can have an ETL pipeline, which loads it into data warehouse. And that allows you to do that business intelligence and reports with the mixture of structured and unstructured data. This is also really powerful in terms of data science and machine learning, because that data science and machine learning can access those images, those CSVs directly without having to go through the data warehouse itself. And so as data science and machine learning have gained popularity and people recognize the power in these tools, that has really driven the need to have access to unstructured data. So as the data lake evolved and as more companies adopted this approach, there became a demonstration of a need for having a little bit more powerful tool to organize everything, to govern it, and to see how it changes over time. And that was where the data lake house was born. So a data lake can be a blob storage with CSVs in it, and you have an ETL pipeline. A data lake, you're going to take all of your structured, unstructured, and semi-structured data, whatever form that comes in, and you're going to convert it to a Parquet file format, loading everything into your Parquet file format. Then you have a lot of power because of the compression that enables, and especially the metadata that's incorporated into the Parquet file format. And the Parquet file format and the data lake house is what underlies a tool like Databricks Delta Lake and Microsoft Delta. The Delta concept allows you to see how your data is changing over time, and it synthesizes all of these different file formats that you have into a single format, and it empowers you to have powerful metadata and powerful data governance, and unifies the approach to business intelligence, reports, data science, and machine learning. So now, instead of your data science and your machine learning going to a database on one hand and to some files loaded into another place on the other hand, it can go to the single data lake house to incorporate that all together in a single source and unify your approach to data analysis. So this whole concept of medallion architecture, this particular name for this, comes from Databricks, And as part of their Delta Lake, they have the concept of bronze, silver, and gold tiers. What can differentiate my approach to medallion architecture is that it does not have to exist only in this concept. I think I want to be sure to give credit to Databricks for really popularizing this particular framework. But I also want to take it and see how it can be applied in any different context. So in our case, at my company, we're using data warehouses, Synapse data warehouses, uh, primarily for our data warehousing, as opposed to a data lakehouse. Uh, Over time, we'll probably incorporate more data warehouses into a data mesh. For now, we have a lot of skilled people at our company with SQL Server experience. So moving from SQL Server to a data warehouse is a very seamless transition. And we can still apply this medallion approach to using a data warehouse, and that's what inspired this presentation. In the Delta Lake concept, the bronze tier starts when you load your data into the Parquet file format and into the Delta format. That's when the bronze tier starts, and before that, you have a pre-landing zone where you can load some data perhaps into blob storage before it gets converted into Parquet. So for Delta Lake, you convert your data to Parquet, and that's when you are loading your data into your warehouse. That load process then leads to the silver tier, which is the transform, and the gold tier, which is where you're going to be relying on that tier for a lot of your business analysis. So starting with this concept here, we can take it and generalize it to our approach, whether or not you're using Delta Lake. And just to explore the idea of data lake houses a little bit more, you don't need to use Databricks Delta Lake to have a data lake house. And in addition to Microsoft data lake houses, there are also some other options, Iceberg and Hootie, and I believe Snowflake as well. These are all tools that you can have data lakehouse in, and you can have the ACID compliance. But the concepts that you're using in these different tools aren't limited to just them. So how can we take these idea of the medallion tiers of a data warehouse and expand it a little bit, generalize it, and see how you can use it as a tool to develop your data pipeline and strengthen your ability to do observable data lineage and strengthen your ability to have flexibility down the line as your reporting needs change, as they inevitably will change. So the concept of hops has existed in data pipelines from before Delta Lake. And I think they took a particular approach that really helps put a point on these hops and has inspired me to really think about analyzing each hop that you make and making deliberate choices at each hop that give you that powerful data lineage, as well as enabling you to have flexibility for your analysis. So we've got some cute foxes here. So let's break up our data pipeline into these tiers. On the left, we've got the untransformed extract. Again, we're talking about an ELT pipeline as opposed to an ETL. So we're extracting it and then we're loading it. The bronze tier is when you load your data into your warehouse. This can look like a simple SQL query where you're querying a relational database, a transactional database. You're querying the data from there and loading it directly into your database. That's your load. In the silver tier, we're then transforming that data and using data modeling. So that can look like Kimball to dimensional modeling to create a coherent data model to empower your data analysis. And then finally, in the gold tier, you're taking that data model and you're doing particular statistical analysis, or you're selecting pieces of it that are important for different business reporting needs. You're editorializing it and loading it into a final tier that's going to empower your reporting directly and give you really quick reporting and reduce your need to do expensive computations frequently. So let's say you've decided how you want to implement your Fabric implementation, and now you're ready to bring data together from a variety of different sources. What do some of those sources look like? You can have transactional databases. So a transactional database would be a database underlying a web application, and it can also be the kind of database underneath an enterprise resource planner. A lot of enterprise level companies are going to have an ERP, and there's a lot of really important and valuable data that's loaded into that ERP, but that's stored in a database format that's optimized for making transactions or doing different business processes. So you're tracking time, you're tracking expenses or income. And so a transactional database is optimized for tracking all of this data and loading it for the actual transactions that you're doing. It's not optimized for reporting or data analysis. That's where the data warehouse comes in, and why we need to separate the data warehouse from the transactional database. Other sources of data could look like a digital asset manager. I previously worked at a company called Widen, where you would load your images into this software and it would help you organize them, tag them, and be able to share them out a lot easier. So you may have a lot of assets in a digital asset manager, and you may want to incorporate some of those assets into your data analysis, and you can do that through your data warehouse. Other sources of data could look like a customer relationship manager. It could look like rich text documents, Word documents. And then you may also have, for instance, reference databases. So these could be databases that store information that give a new level of richness to your underlying data, and add additional context to it. You may want to incorporate that into your data warehouse so that at the reporting level, your data is already contextualized by the time it reaches your Power BI reports. Another source of data could be streaming data. So that could be Internet of Things. You may have sensors in a building tracking the temperature over time. You may want to record that data. That can be a large amount of data, and it can come frequently. It might be in small bits, and you'll need to organize that and keep track of it. So let's say we have all of these different sources and we want to bring them together to do analysis. What are some of the challenges that are going to come up as part of that? The challenges could look like having the same business model having different names in different databases. So if you have a customer relationship manager application, as well as an enterprise resource planner application, you may have a client, and that client may be represented differently in those two sources. So you need to bring those two sources together and merge them in a consistent way that has a very high level of accuracy so you can trust your reports. these different sources of data may have different database schemas. So if you have, let's say you have multiple ASP.NET applications and you have a SQL Server database underneath it, even if you're using the MVC framework for and have multiple applications at the same company with the same developers, you can have two different applications with both using MVC that have differences in the schemas of those two databases. So again, you'll need to bring in those different sources with different underlying schemas and make them consistent over time. Another very common challenge is having different data types. So let's say you have a Boolean data type, true or false. Let's say, in one database, you may have that represented by a 0 or a 1. Having just a bit type, and if it's 1, it's true. If it's 0, it's false. Then you'll have another database where that could be represented with a literal string of the letters TRUE and FALSE. So you'll need to take these two databases with different ways of representing this Boolean value and make them consistent within your database. So you'll need to transform one or both of those data sources to have the same data type within your data warehouse. Finally, one last challenge that can come with dealing with a lot of different sources is granularity. So you may have one source that tracks temperature in a room over time that's tracking it by the minute. And then you may have another source that is tracking the number of people who enter a room, and that is tracking it by the hour. So on one hand, you have something being tracked in minutes. On the other hand, you have something being tracked in hours. And you'll need to transform, again, one or both of those data sources so that they now have a consistent level of granularity. So those are some of the challenges that can come with data wrangling, of taking all of these different sources together, bringing them together to do your data analysis. So understanding your data sources is very crucial before you start your data pipeline. So as you're extracting, transforming, and loading your data into your data warehouse, you really need to have a deep and thorough understanding of the data in situ, as it lies. What is the meaning of that data? And the only way to do that as a data engineer, such as my role is to engage very closely with the business stakeholders who work with that data. So if you have an enterprise resource planner, that data is stored in a particular way, has a particular meaning, and the only way to really understand that is to work with the domain experts who create that data and work with it every day. The more closely you can create feedback loops with the people who use that data in its original source, in its transactional database state, the more deeply you'll understand the meaning of the data. And that understanding is crucial to later down the line when you're doing analysis, making sure your analysis means what you think it means, and that your data is contextualized with the proper understanding of where it comes from and what it truly means. So, it's hard to emphasize enough how important it is to really dig into the full meaning of your data sources. So here we are. Finally, we can talk about the medallion tiers. The first tier is the bronze tier. Bronze tier is the landing zone. So there's this, in some ways, maybe the most important step in your data pipeline and in your data warehousing process. When you're extracting data from one source and loading it into your database, your data warehouse, that's a hop. So as you extract that data, you're now having a certain amount of duplication of data, and that has expense that has costs in terms of simply processing power and storage costs, but it also introduces opportunities for your data warehouse to start to diverge from the data source itself. So as I was working on this presentation, I came across an article that talked about how you should try to have the fewest number of hops as possible, because every time you do a hop, you're introducing a chance for errors, misunderstandings, and you're increasing the cost. I think in the modern age, for the needs of an enterprise level company, you 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 kind of need to do hops in your database and your data warehouse. It's kind of a necessity, and since it's a necessity, I think it's really helpful to think about each one very carefully, what the concerns are, and how you can approach it in a consistent way. So you may need to do change data capture. If you're using a SQL Server database as one of your sources, you can turn on the feature called change data capture and see how rows in that database are changing over time. If you track changes to data over time, that gives you an opportunity for analysis that you don't have when you're just looking at the data in its current state. So when you take a table and you're tracking changes to it over time, now you have a new table that has non-unique references to the same object. So if you have a client and you're tracking changes to your clients over time, now when you look at your table tracking those changes, when you query for that client, you'll have multiple rows. You'll have multiple results for one client because you have the client at each step that you changed it. So I would refer to that as being a decomposed table. The original table would be composed, and then when you decompose it into tracking the changes over time, now you've introduced a new level of complexity. That complexity is a cost, but the benefit to it is new opportunities for analysis. So in your bronze tier, you can land that decomposed table to track the changes over time. And I think it's also helpful then to take that decomposed version of that table where you're tracking the changes and to recompose it. So this recomposed table will mirror your original source. It will look the same and have the same data at the same time, as long as you're being careful about your process for extraction. So some other structured parts of a bronze tier can look like those reference tables I was talking about earlier. You may have also a lot of metadata that you can add to your source data, and you can have the streaming data that we talked about as well. In your bronze tier, you also have the opportunity to introduce some unstructured or semi-structured data. You can load CSVs, you can load Excel files, you can load text and PDFs. Those can be in their original format and they can be in Parquet. Just to go back to the Delta Lake example, in Databricks Delta Lake, they refer to that bronze tier only after it's been converted to the Delta Parquet format. In this conception of a bronze tier, your blob storage is also part of your bronze tier. And I think it's helpful to think about that pre-landing zone when you're incorporating your entire data pipeline, because you really need to be careful about those original extraction steps. And you need to have a careful approach to make sure that you have a full data lineage and that you're not introducing misconceptions at that step. So the bronze tier is really crucial for having a high level of accuracy later on. So a couple of considerations for the bronze tier is to how much transformation do you want to introduce at this step? You may want to not introduce any transformation at all, and you may want to have a little bit to just ease the pipeline later on. And in one case, the example I would give here is that if you are working in a context where you as a data engineer or somebody working as part of a pipeline, if you have full access to your sources of data, where you can even introduce changes to the schema in your source database, then you have a little bit more freedom to do some light transformation in your bronze tier hop. On the other hand, you may have a scenario at your company or for a client you're working for where you really have almost no visibility into those original sources, and you just have the data by itself. And maybe you don't even have somebody that you can work with to help you understand it and gain that deep understanding. Excuse me. So if you have a case where maybe you don't have as much access to your source data, you want to have a higher level of fidelity when you do that original bronze tier hop, because that will help you be sure that you're not introducing any misconceptions in your early transformations. Some other considerations at this stage are the change data capture I talked about earlier. Excuse me. How much do you want to track the changes to your data over time? For some things, it may be very valuable to see how something changes over time. Maybe you'd really like to know how all of your interactions with your clients have gone, and in your source data, you may not have the visibility into those changes. In that case, you'll want to really capture the details of how that relationship with your client changes over time. And so you'll want to have that historical data for that data model in your bronze tier. Then you may have some other data models in your sources that you're not as interested in tracking the changes to over time. So in that case, you don't need to do change data capture. You can just grab the current version and load it in. In addition to that, we've got reproducibility of the source environment. I think this is a really interesting question. Maybe you have somebody who works on one of your data sources who is already doing analysis. That person, if you're able to sort of reconstruct the original data relationships in your bronze tier, that person might be able to take their existing queries and move them to your data warehouse and be able to transition very seamlessly into using a data warehouse for analysis rather than your source data source. In that case, you're going to be able to reduce the demand on your data source and move that demand for analysis into your data warehouse. And you can save money, you can save time, and you can make that transition from doing analysis in one place to doing analysis in your warehouse as seamless as possible. So in other cases, that may not be a concern for you. So you may not need to be able to kind of reproduce your source environment, in which case you don't need to worry too much about that. In addition, we've got isolating stages with high probability of error. So if you have a situation where your extraction process, that step has a high opportunity for error, let's say there's perhaps connection issues where frequently, as you're doing an extraction, maybe that extraction will fail. If that's the case, the more you can isolate the step of extraction from transformation, the more you can debug that extraction process without affecting the rest of your pipeline later on. Data governance, I think, is also really crucial to call out at this step. Data governance being a huge concern, because in your source data, that's going to be your most secure location. And introducing a data warehouse and reproducing some of that data in your data warehouse, now there's a new opportunity for people to get access to data that they shouldn't have access to. So the bronze tier is where you want to have the most data governance, most secure level of access. in line with the principle of least privilege. So you give only as much privilege to accessing your data as somebody needs to do their job and no more. You need to give that amount of access in order for them to do their job, but you don't want to give them any extra access to something that doesn't help them. So in terms of making sure that only the people have access to the data that they need, the bronze tier should be the most locked down tier in your database and in your data warehouse. So now we get to probably, in my opinion, the most exciting part and most kind of intellectually challenging part, the silver tier. Silver tier is where you'll transform your data into a new data model that will allow you to do really powerful data analysis. So a common approach here is dimensional modeling. It's not the only approach, but it's very, very popular. So that will be Kimball approach, or there's several others as well. And you can use entity relationship diagrams to document that data model. Those diagrams can help be a living documentation for the model that you're using to do your data analysis. You could do a whole presentation just on dimensional modeling, so I won't get too much into it. But being able to take your data from your source and model it in a way that's going to facilitate data analysis, this is a crucial step in your data warehousing, and it's worth a lot of attention, and it's worth a lot of discussion amongst your team. So a big part of doing that silver tier data modeling is, again, going with the people who work with the source data and with the people who do the business analysis to make sure that your data model represents accurately how the data is used in its transaction state and how you want to do analysis on it. So you can bring together different roles within your firm and talk about what is this data and how do we want to look at it. A really powerful concept that I learned in my previous role as a software engineer is the idea of ubiquitous language. This comes from domain-driven design, and it's the idea of building up a canonical and unambiguous language between everybody involved in your software development process and in your business analysis as well. So it's a shared language that you can use as an engineer, as a developer, as a marketer, as an analyst, to talk about the same thing and make sure everybody understands what each other is talking about. And this is kind of the hard and the nitty-gritty of working as part of a big team or a company, is making sure that everybody's kind of on the same page. And you want to have your data model in your silver tier represent that shared understanding between not only you as a technical person, but also as your analysts downstream of your data warehouse who are consuming your data warehouse. Make sure that when you're talking with them, that you're talking about the same thing. Because again, a data warehouse as a source for data analysis is being used to make really important business decisions. And due to how important it is, you really want to make sure that everybody's on the same page. And so the silver tier is a great place to bring together all the great minds at your company and become really aligned on what the meaning of your source data is, what the meaning of your analysis is, and that shared understanding can be built directly into your data model. And the more time and effort and consideration you put into that process, the more confidence that you can have in your data analysis that what you're looking at is what you think you're looking at. And it seems kind of silly to talk about that, but I think the cost of having a misunderstanding at this stage in your data warehouse can be really huge, because if you have a misunderstanding here, everybody downstream doing analysis will be consuming that misunderstanding. And that can have really bad effects when you're talking about data analysis and making decisions within your business. So finally, to talk briefly about the gold tier. In the gold tier, we have the idea of this is where you're landing all of your data, and where you can consolidate the data from your silver tier into specialized tables for specific reports. And at this stage, you're going to work really closely with your analysts and talk about the KPIs, the metrics and measures that your company uses, and really hone in on what the analysis needs are, because the more fine-tuned you can become with your KPIs and metrics, the more powerful decision making you're going to be able to empower your data analysts to do. So a measure might look like a sum or an average or a count. So how many clients do you have? That would be a count. We've got 3,000 clients. And if you were to skip the gold tier altogether and only have a silver tier, then you every time you're doing a report, you wanted to figure out how many clients you were, that's going to have an expense for the computation of that count. So you want to, in order to avoid that expense, you can pre-calculate that. Every day you can go to your silver tier and say, how many clients do I have? That's going to give you a number, 3,000. You take that number and you load it into a gold tier, into a data mart, and now you've already calculated it, and you could have 10 different data analysts looking at reports and looking at that number, and you don't have to calculate it every single time somebody loads a report. So the gold tier is all about figuring out what KPIs, metrics, and measures you're using in your reports, and pre-calculating them. And that way, when you load your reports, you're not having to do the same calculations over and over again. Another term for the gold tier is data marts. The gold tier might be a collection of data marts. So you might have several different tables, either in a data warehouse or a data lake house, that already have all these preloaded measures and metrics, and allow you to do all that calculation just a single time. And then over the course of the day, as maybe dozens or hundreds of people are looking at reports, you won't have to do the calculation over and over again. So a data mart should be really finely tuned to the reports that people are creating. And so you want to work really closely with data analysts to identify their needs. A data analyst may also go directly to your silver tier and create their own measures, create their own metrics. But, over time, once you identify what some of those common measures are, you can already load them into a table. So besides having a computational benefit of reducing the cost of computation, that is also going to load your report much faster. So finally, what do these different options look like? At your different firm or for a different client, you may want to have a bigger bronze tier, or you may want to have a lot more data marts. So how you break up your data pipeline is going to depend on your very specific data needs for your analysis and your particular use case. So you may have a bigger silver tier, or you may have a smaller one, and working closely with your stakeholders and your domain experts, you can choose what needs are going to match best your data warehouse and how much emphasis you want to put on each step, and what choices you're going to make at each hop along the way. So that's my time. Thanks very much for listening. I'm going to look forward to seeing your comments, and I hope maybe that this sparks some inspiration for you to think about your data pipelines and each step along that, what choice you're making. And the more time and effort you put in that, and the more you can work closely with your stakeholders, you can really have the confidence of your data lineage, and you can really make sure that you understand your data and that your analysis is contextualized and accurate. Thanks very much.